Hey everyone. So we're in the Khan Academy class. In the Pre-Algebra Khan Academy class, Unit 14. And today we're going to take the unit test. So I'm going to go all the way down to the bottom and take the unit test. And hopefully this will help you out. All right, so we got 13 questions, 13 to 26 minutes. So this question says, Jada has a stand in the marketplace where she sells her ground cumin. Her weekly expenses are $300, and she sells her cumin at a fixed price per kilogram. If she sells 120 kilograms of cumin, her weekly net profit is $600. So what I'm going to think about is if she makes a net $600, this is her profit. She brings home $600. But we also know that her weekly expenses are $300. So if she starts the week down $300, she starts the week down 300. She has to then make $900. She has to get an additional $900 to get to the $600 of net profit. Because if you're at negative 300, you need to bring in $900 to then be at positive 600. So what that means is that for 120 kilograms, she sold 120 kilograms of cumin, and the change in her profit was $900. So it looks like the 120 kilograms cost $900. So it's asking, what is the price of a kilogram? How many dollars per kilogram? So it's $900. And I'm going to split this up. I'm going to divide it between 120 kilograms. This is going to tell me how many dollars per kilogram. So it's going to give me, I'll show my calculator. So that is 900 divided by 120. And it's going to be $7.50. So $7.50 per kilogram of cumin. How much cumin does Jada have to sell to cover her weekly expenses? So the weekly expenses is $300. So in order to make $300, if she's selling it at $7.50 per kilogram, we're going to do the 300 and divide that by 7.5. She would have to sell 40 kilograms of cumin to make back her $300. So 40 kilograms. And if you do the 40 times 7.5, you should get 300. So that's how you make back the $300 that you spent. All right, this question says, find the output F when the input T is 7. So I'm going to find the output F when the input T is 7. So this is a function. It's in terms of T. So the input is going to be T, and we're going to put in 7. So what the function says to do is to take 2 times T. So I'm going to take 2 times 7, and then it says I should subtract 3. So F is going to equal 2 times 7 minus 3. That's going to be 14 minus 3. So it looks like that when T is 7, when the input T is 7, the output F is 11. The input T is 7, the output F is 11. All right, let's take a look at this one. It asks how much water was initially in the tub. So I'm going to read this and know that that's the question. So it says Archimedes drained the water in his tub. The amount of water left in liters is a function of time. So this is the amount of water left. This is the time. So it looks like after 5 seconds, all the water's gone. We have 0 water left, and we started with 360 liters. So I think that's what the question's asking, is the initial amount of water. So that would be the 360 up there when the time is 0, when time has just begun. 360. All right, this question says, find the output Y when the input X is -1. So this is a function where the input is X. And if I know the input, so say the input is 2, I know the output will be 2 as well. If the input is 6, the output is 4. If the input is 8, the output is 6. So if the input is -1, the output is 3. So our answer here will be 3. So when X is -1, Y is 3. And I know because that the function is the blue line is showing me what the function. The blue line is showing me the function. When the input is -1, the output is positive 3. All right, so it says Archimedes drained the water in his tub. 62.5 liters of water were drained each minute, and the tub was completely drained after 8 minutes. So what I'm going to do is I know already that on this graph, if I go over to 8 minutes, I have 0 water. So I know this point right here will be on the graph. 8 minutes, no water. The question is, how much water did I start with? Well, if I am draining 62.5 liters per minute for 8 minutes, I can figure out exactly how much water I started with, because that's going to be 62.5 times 8. Each minute is another 62.5. So I'm going to do 62.5 times 8. I don't know why it's giving me a calculator, but 500. So when the time has just begun, I have 500 liters of water at the initial time. And after 8 seconds, I will have gone down to 0 if I'm draining 62.5 liters per second. All right. This says Nala is escaping from the dragon's lair. She is running towards the entrance of the lair at a speed of 9.2 meters per second. Run, Nala, run. The entrance is 180 meters away. So we have the entrance is here, and it's a distance of 180 meters. It's 180 meters. And Nala is running, I guess, towards the door at 9.2 meters per second. So after 1 second, she's gone 9.2. After another, she's gone 18.4. Keep adding that, 27.6. So she keeps adding 9.2 every time. Write a function. So write the function's formula. So we need to figure out, what does the function represent? D. It says the distance D between Nala and the entrance of her lair is a function of t, the time. So how far is Nala over time? Well, at the start, she's 180 away. So I'm going to say her distance at the start, it's 180. So I think that's a reasonable place to start. Then what's happening is, over time, we are reducing the distance by 9.2, her rate. So what's going to happen is, for every additional second, every time I add another second, I'm actually reducing the distance to the door by 9.2. So each second is represented by t, another second. So I'm going to do 180. Oh, did I do 188? I should have said 180 minus, the distance will get smaller. Every second, it will get smaller by 9.2. So I'm going to do, the distance between Nala and the door is 180 minus 9.2 t, because for every second, she's going to get 9.2 meters closer. So this question says, there are 2 submersibles, one red, one blue, started rising towards the surface at the same time. They rose at a constant speed. So we have a red submersible and a blue submersible. 2 submersibles. So because they're submersible, I think that means they're probably underwater. They're being submersed. So they're down here, red and blue. And it says the red submersible started rising from an altitude of 80 meters below the surface. So that, currently, it is 80 meters below. So this is a distance of 80 meters. And after 30 seconds, it was 60 meters below. So it traveled here to where the distance is now only 60. So this distance would be 60. So that means we traveled a distance of 20. We traveled 20 meters, 30 seconds. So let me correct that. So 30 seconds, 20 meters in 30 seconds, that's now 20 over 30 is 2/3. So the red is traveling at 2/3 of a meter per second. Every second it travels 2/3 of a meter. It says the following equation gives the altitude in meters of the blue submersible as a function of time. So this submersible, at 0 seconds, when time is 0, it starts at -90. So it starts even further down here. So maybe I'll erase this. It starts at a distance of 90. It's way down here. The distance is 90. And that the equation tells us that the distance, the original starting distance is 90. And then the rate is 0.6. So every additional second, we're going to go up by 0.6 meters. 0.6, 0.6, 0.6. So every second, this blue one is traveling 0.6 meters. So this is going to help us answer both questions. So the first question says, which submersible started rising from a higher altitude? That's kind of a weird question. I think the red one is starting at a higher altitude because it's closer to the surface. Which submersible rose faster? The red submersible is going 2/3 of a meters per second. So in decimal form, that's 0.67. If you divide that out, it's 0.67. Rounds to 0.67 meters per second. The blue one is going 0.6 meters per second. So the faster one is red. Red is going at a faster rate per second. So I think it's going to be both red. This question says, Andre wants to fill a glass tank with spherical marbles and then fill the remaining space with water. So it's a glass tank and there's a bunch of marbles, and I guess they would kind of like stack on top of each other and they would fill this whole space somehow. And then we're going to pour water in to fill the empty space in between all the marbles. And maybe this will go all the way up. So the variable W models the amount of water in liters Andre uses if he uses n marbles. So I think you're going to need less water if you have more marbles. I think that makes sense. The more marbles you have, the less water you can fit. And the equation here shows that the amount of water that we have is 32 minus 0.05 times the number of marbles. So for each additional marble that we add, we're going to have 0.05 less liters of water. Mathematically, that means that the marble itself has the same volume as 0.05 liters of water. So I'm going to say the volume of each marble is 0.05 liters, because for every additional marble, that's how much less water you can put in the tank. All right, so this is a yes or no question. It says the table compares the capacity of Omo Jobi's phone's battery when he started charging it in percentage points and the time it took the battery to be fully charged in minutes on several different occasions. So what was the initial capacity and how much time did it take to charge? So my guess is that if it starts at a lower capacity, like 40, it's going to take more time. It's going to take 30 minutes. If it starts at a higher percent, like 65, it's going to take less time, like 18 minutes. The problem here is like this one starts at 65 and it takes 18 minutes, but here it starts at 65 and it takes 20 minutes. So it seems inconsistent. If you know the battery percentage, that doesn't guarantee you know how much time it's going to take to charge. That means that the charging time, it's not a function of the initial capacity. It's not a function of the initial capacity, because knowing the initial capacity does not guarantee you know how much time it takes to charge. You can see that here with the 65. Just because you know it's 65%, that doesn't guarantee you know how much time it takes to charge, because one time it took 20 and one time it took 18. If you look at the 30, it's the same thing. 30%, 30%. So is the charge time a function of your initial percent? No, because if you know the initial percent is 30, you can get different charge times. So this is not a function. The charge time is not a function of the initial capacity. The following figure shows the entire graph of relationship, and the question is, does it represent a function? So with a function, every input can only have one output in this function. So this is, say, f of x, and that's represented by this blue line. So maybe I should do it in blue. F of x. This is f of x. So this graph that it's showing is representing f of x, and I'll probably erase this, but this is f of x. So the question is this a function? So a couple ways to figure it out. So for all the inputs, they have to have exactly one output. So if I look at the input 2, for example, my output is -4. And there's no other output when the input is 2. When my input is 4, my output is 0. When my input is 5, my output is 5. But when my input is 5, I can only have this one output. If there were any other output, this would not be considered a function. So for example, if I had, and it'd be a little weird, but if I had like another points here, this would now not be a function, because when the input is 5, there are these two different outputs, 3 and 5. But in this case, it looks like every input has exactly one output, and you can use what's called the vertical line test. So if you draw as many vertical lines as possible, you should never be able to cross a function twice. If you cross a graph twice with a vertical line, it's not a function. So as I keep drawing these vertical lines, I am never going to cross this graph twice. Even though as I get like towards the edge, it's going to feel like it. It's actually not going to cross twice. So I'm going to call this one, yes, a function. Right, this says function 1 is defined by the equation d equals -3/7t minus 4. Function 2 is defined by the following table. Which function has a more negative slope? So this first function, it's a linear function, and the slope is -3/7. So the slope is -3/7. Thinking of this in slope-intercept form, like a nice little y equals mx plus b, where m is your slope, the coefficient that is with the variable in the function. So our slope here is -3/7. So which one's more negative? This slope. So to find the slope, it's the change in y over the change in x. So here, the change in y is -1.2 because y goes, or the output goes from 2 to 0.8. So it goes down by 1.2. And I'm going to divide this by the change in x, or the change in my input, which is 2. So the rate here is -1.2 divided by 2, which is -0.6. So this has a downward slope of -0.6. This one has the first one has a downward slope of -3/7. Which one is more negative? 0.6. This is going to be not even -1/2. So this is going to be more negative. The -0.6 is more negative. So that one will have the more negative slope. So we'll say function 2. All right, it says rearrange the equation. So R is the independent variable. So even if you don't know what this means, it sets it up, your answer right here. It's basically saying you need to solve for Q. You actually need to solve for Q. It's kind of the opposite of what you might have thought based on the question. But the answer is set up where that's the only answer it will accept is Q equals. So if I want to get Q by itself, maybe I would add 5R to both sides. So I'd have 10Q equals 30 plus 5R. And then I would just divide both sides by 10. So I think in my answer box, I can make this a fraction. So I'll have 30 plus 5R, and that is all going to be divided by 10. And that's going to give me Q by itself. All right. Let's take a look here. All right. So weird little graph with beats per minute, it looks like, over time. Okay. So it says a doctor observes a graph that shows the electrical activity in volts of the heart patient over a period of time in seconds. Each spike corresponds to 1 beat. The doctor needs to calculate the rate of the patient in beats per minute. Oh, because I think there's 2 ways to interpret this. I think you could say it's a beat per second. So that's going to be 60 beats per minute. I think that's what it's going to like, even though technically if it beats at 0, there should be 61 beats. But I think I could tell the question was going to like the 60 because we're beating at 1 beat per second. Every second there's 1 beat. All right. Very nice. So I hope this helps and have fun.